All right, we're gonna go ahead and get started. That'll come up in just a minute. We're gonna start on 3.2. We're not doing a ton today, just a couple of pages, and then um, you'll get some homework. On Wednesday, make sure that you guys are doing your vocabulary and anything that you have missed. I want you to turn that stuff in. Some of you are getting absences left and right because you're not doing stuff at home, and that's not good. Okay, so when you're not here, you need to log in and you need to do your work. Otherwise, you get an absence. And remember, if you get more than 4 absences, even if it is exemptable, you will not be able to exempt. So make sure that you're at least worried about that if you're not worried about anything else. So 3.2 is going to start talking about least squares, regression, and correlation some more. We're going to calculate and interpret residuals. We're going to use a least squared regression line, which we already know how to do. Again, we just use our calculator and we choose the other regression. So we're going to move down to correlation measures. It measures direction and strength. I just had you get them.
Ms. Jones,
Yes.
on Fridays, do we have to turn in homework like Friday night, or is it just any time on the weekend?
Pretty much anytime on the weekend, as long as I have it by Monday morning, because it's going in the grade book.
Okay.
All right. A regression line summarizes the relationship between two variables, but only in a specific setting. And that's when one variable helps to explain or predict the other. A regression line is a line that describes how a response variable y changes as an explanatory variable x changes. Sorry, this thing is driving me insane today. We often use a regression line to predict the values that should say of y for a given value of x. All right, so regression line is just another name for line of best fit. We've done line of best fit for many, many years, okay? So it's the same thing, nothing any different. All right, regression lines as models. Everyone knows that the value, I don't know what that says. The values can, I don't know. Anybody know what that says?
I think it says cars and trucks.
Yes,
Yeah.
that is great. Lose value the more they are driven. Can we predict the price of a used Ford F-150 Super Crew 4x4 if we know how many miles it has on the odometer? So, like if you look up your car in like Kelley Blue Book, if the lower miles it has, the better off you're going to be. Also, the newer it is. So as it gets older and as you have more miles on it, it loses value. A random sample of 16 used Ford F-150 Super Crew 4x4s was selected from among those listed for sale at autotrader.com. The number of miles driven and price in dollars were recorded for each of the trucks. Here are the data. Plot the data along with the linear regression. What is the correlation? So we are going to go ahead and put this in. This might be the last time that I make you do this. It may not be, but remember your miles driven are your X's, your price is Y. So you're going to change your L1 and L2. And you're just going to put it into stats. So go ahead and start doing that. And it will take you a little while. The worst part's putting it in, I promise. Everything else is easy. While you're waiting, those of you that are already done, make sure your stat mode is on, stat diagnostics is on. Otherwise, it won't show the regression. All right, so those of you that are finished putting it in, those of you that are, you can listen at the same time. We're just gonna do our linear regression, but remember that we do the 8, not the 4, okay? So we want the B plus AX. So stat over to calc and down to the number 8, A plus BX. That's the one that we want. And we're just gonna keep hitting enter, and then it's gonna give us everything we need. So it says plot the data. If we wanted to do that, how do we plot it? I'm not gonna do it, but how do we do it?
How do you turn this stat one?
Go to mode and down to stat diagnostics and turn it on. All right. So remember, you can go into stat plot, and if it says draw it, like on your homework, if it tells you to draw it, I don't want you to literally draw it. I want you to do it on your calculator. Okay, there's no point drawing a scatter plot. And then make sure it's in scatter plot and then zoom 9. And so there's your scatter plot. What do you notice? Tell me how you would
Negative.
describe this. It's negative.
A pretty strong
A
negative
moderately
correlation.
Moderately strong.
correlation.
Okay. What else? What do you see?
A
There's
gap.
a gap.
Gaps. I wouldn't go with outliers yet. I would just go with gaps. So yeah, there's a gap in between there. So that means there's 2 clusters of data, and then you would want to define where those 2 clusters are. Okay. So again, just reiterating how to describe this data set.
Jones,
What?
if you have a cluster really far away, doesn't it make it so that they're not outliers because it throws off the IQR? Does that,
Yes. That's why I said don't use outliers right now.
I don't know if that's how it works.
Outliers would be a high, like a really like high point this way, or like one that was low right here. Same thing here. It would be really high on this end. So there's not really any outliers right here that I for real see. Okay. All right. So going back, stat calc, you guys were here. So plot the data, we did that along with the linear regression. So here's your correlation. What is your correlation?
Negative 0.81.
And I'm gonna go ahead and go 3 decimal places. I want you guys to start doing 3 decimal places, please. Stop rounding to the whole percent. Go 3 decimal places. What does this mean? You said, some of you said moderately strong, but this is actually pretty strong, right? An 8 is real close to a 1. So strong and negative. The linear regression is the equation. In your calculator, it tells you y equals a plus bx. Our a should have been 38,257. Sorry, I forgot my 7.676. Plus our b was negative 0.163, and then our x. Okay. If you got a little bit different numbers, those are the correct numbers. Those are the correct numbers. So if you got something a little different, you just put one of your values in wrong. So it's not a big deal. The biggest thing was showing you how to do it on your calculator, okay? So when you do your homework and you do your test, go back and check those values real fast before you start doing all your calculations. Is everybody good? All right, next page. A regression line is a model for the data, much like density curves. The equation of a regression line gives a compact mathematical description of the way this model tells us about the relationship between the response and the explanatory. Suppose that y is a response variable that's plotted on the vertical axis. You already know that. And x is an explanatory plotted on the horizontal axis. That's where x and y goes. A regression line relating y to x has an equation in the form y equals a plus bx. And then they put this little symbol over the y. They call this y hat. Looks like a hat, okay? That means it's a prediction, okay? That line of best fit means it's a good prediction for anything you plug in. You're not gonna get the exact value. If I plugged in a certain amount of miles, I may not get the exact value of the truck, but I'm gonna get pretty close to it. So it's a prediction equation. So that little hat just means that it's a prediction. So y hat is the predicted value of the response variable y for a given value of the explanatory variable x. B is the slope, the amount by which y is predicted to change when x increases by 1 unit. You already know that. That's from Math 1. That's from 8th grade. Okay, the number with x is your slope or your rate of change. A is the y-intercept. The predicted value of y when x, or the explanatory, is 0. And then it says, why do we use y hat equals a plus bx? There are 2 reasons, and they're like the dumbest reasons in the whole world, but makes sense. It's simple, and your calculator can do it. Okay. Now they're also going to eventually give you a set of data where you have to pull like those mini tab outputs or whatever, where you have to pull the equation out of there. It's really simple. You just got to remember which one's which. And that's the biggest deal, is a lot of times they get reversed. So make sure it's the same every single time. There's nothing any different. So just make sure you remember. All right, interpreting the slope and y-intercept. The equation of the regression line shown in the figure. So sometimes they'll change the y to the actual value of the variable. So this one dealt with price. We're talking about those trucks and the miles driven. So the predicted price, we said our equation was 38257. And I'm going to put minus instead of plus negative. 0.163. And our explanatory units were miles, or our x value units were miles. Now, here's the thing. If you write this on your AP exam, this is covering yourself for units and everything else. If you write it like this, like we did on the other page, you have to define that y hat is price and x is miles. So it's much easier to go ahead and just write it in your equation, okay? But you have to do one or the other. Does everybody understand? So when we get to our test and you just give me this, what is going to happen? You going to get the right answer?
Gonna be
You're going to lose some points. You're not going to lose all of them, I promise, but you will lose some points because we have to define our variables. Always define any variables that you use. So it says identify the slope and y-intercept of the regression line and then interpret. Interpret each. I know that this is on your homework tonight, okay? So which one is your slope?
B.
Yep, what is it?
Negative 0.163.
And how would I interpret this? It is the same way every time. You just change whatever units you're working with. So it's the
Where did you
predicted-
get that number?
right here in the equation. It's your slope. It's the number with x.
Oh. But where did you get that number from?
We
Is
did
it
it.
always that number?
We did it in our calculator just a second ago.
Oh, okay. Never mind.
That's okay. All right. The predicted price decreases. Why is it decreases?
It's a negative slope.
Uh-huh. By, how do I write this as money?
$sign 0.163.
You can, or I can say what?
16.3 cents.
Uh-huh, 16.3 cents. I don't care which way you write it. Per, what was our X unit?
Mile.
Mile.
driven.
Yep. Perfect. So again, this is the same equation every single time. The only thing that'll change, predicted, whatever your Y value is, increases or decreases, whatever value is, per your X. Does everybody understand that? Okay, put it in the context of the problem, but it never changes. All right, your y-intercept. What was your y-intercept? Come on, guys.
38,257.
Y'all sitting in here have to start talking to me. Okay, it's boring. Y'all are making it boring. So thank you, Zoomers. People sitting in here, talk. 38,257. So we identified it. Now we have to interpret it.
That's how much a car costs if it hasn't driven a mile before.
What kind of equation are we using? Why do we have the little hat? Predicted, we gotta have that. It is not how much it costs. It is the predicted price. Okay, so be careful putting that because you will lose points. In context of the problem, predicted price of what?
Car that is 0 miles.
What are our cars? F-150s, right? 4x4, Super Crew, whatever. You can write all that. Driven 0 miles or with 0 miles is perfectly fine. With 0 miles driven, it doesn't matter. Do not lose points because you are too lazy to learn how to write this. Okay? It's the same thing every time. That is exactly what the AP exam wants. So I will be pretty harsh on that if you guys don't put it the way it's supposed to be, okay? Understand. Next page. Does a small slope mean that there is no relationship? So slope from the last example. Was negative 0.163. This does not mean change has little effect. on money. It just depends on the units. So basically what it's saying is if it's a small slope like this, it doesn't mean all the time that it's just going to have a little bitty effect. It could have a large effect. It depends on what you're working with, what your units are working with. So 16 cents on thousands of dollars is probably not going to be a big deal. But if we put 16 cents on $1 or something like that, it makes a big difference. So this is what it's getting at with this. You can't say how strong a relationship is by the slope. Okay, so just because that slope's really little doesn't mean that there's not a strong relationship. Okay, what shows you a strength in the relationship? What shows you the strength?
R value, the correlation.
The correlation. Thank you, Rachel. All right. Prediction. We can use a regression line to predict the response y hat. And remember, the hat just means prediction for a specific value of the explanatory variable x. All right, so still going with that truck equation. Remember, he said the predicted price, same equation that we've been doing. Oh, sorry, that should be a 5. 38257 minus 0.163 miles. If a used Ford F-150 has 100,000 miles driven, what would you do? To predict,
You plug in the
again,
miles.
so you would do price equals 38257 minus 0.163 times 100,000. And I'm not going to make you do it, but it gives you 21967. Make sure that you have your units on there. So your units is the $sign. Can we predict the price of a Ford F-150 with 300,000 miles? Can we? Sure, let's try. So we have price, predicted price equals 38257 minus 0.163 times 300,000. Somebody tell me what you get for that.
Negative 10,000.
Did you get 43? Okay, sorry. Did I see that? What's that saying?
Your
It's
clock's not working.
negative amount of money.
Scrap it.
Yeah, but what does that mean? If it's negative 10,643.
It's worth a negative amount of money.
That means you buy it and they pay you to take it.
Right, right. So that means if I wanted to get rid of this truck, I would have to pay you to get rid of it. That's exactly what that means. Y'all see that? Does that happen?
No.
No, that's not going to happen. So why is this wrong? Why is this wrong?
Because nobody's going to pay you.
Okay, but why did it happen in the equation?
Because
at some
the
point
equation doesn't have those
passes
factors.
the,
Okay, y'all are talking at the same time. I heard Kyle, Rachel, tell me what you said.
I said at some point the equation will cross the x-axis and start to become negative.
Yeah, so what this is actually extrapolation. You've probably not heard that since Math 1. So our prediction line is only good for our data that we had, okay? If we look back at our data, there is no truck data that is 300,000 miles or greater, okay? So we don't have that data in there. So this extrapolation, this should say is, the use of a regression line for predictions far outside the interval of values of the explanatory variable x used to obtain the line. So exactly what Rachel said, it does eventually, that line of best fit does cross over the x-axis, so then we're not using the correct ones. So such predictions are not accurate. So don't make predictions using values of x that are much larger or much smaller than those that actually appear in your data. So whatever your smallest one is, don't go below that for your mileage, okay? We're gonna try to get the check your understanding in, and then we'll have to go back in and come out, or go out and come back in. All right, some data were collected on the weight of a male white rat for the first 25 weeks after its birth. A scatter plot of the weight in grams and time since birth in weeks shows a fairly strong positive linear relationship. The linear regression equation is predicted weight in grams is equal to 100 plus 40, and then the number of weeks, or the week number. All right. What is the slope of the regression line?
100.
We got it again.
Oh, 40.
40. Interpret it. What does it mean?
Every week the rat lives, it gains 40 grams.
Rat gains 40 grams per week. What's the y-intercept? Perfect. What does it mean?
A newborn rat weighs 100 grams.
At birth, what you said is perfectly fine. At birth, a rat weighs 100 grams. You can absolutely say a newborn rat. Predict the rat's weight after 16 weeks. It says show your work. This is where I'm talking about. Go ahead and put your weight. You want to rewrite that equation. Sorry, I should put my grams. Equals 100 plus 40 weeks or week. We're trying to predict the weight, so we're going to keep that in there. But we're trying to predict 16 weeks. This way they know that you plugged it in for the right thing. You know exactly what you're talking about. And then we get the weight in grams is equal to 740. No, I cannot write today. So your answer is 740 grams.
Do you need to keep the hat above the?
Yep. Thank you. Should you use this line to predict the rat's weight at age 2 years? Use the equation to make the prediction and think about the reasonableness of this result. There are 454 grams in a pound. So if we try to predict this, how many weeks is it?
104.
When we put this in, we get 4260 grams.
A
So
fat rat.
it tells us there are 454 grams in a pound. That would make a 9.41 pound rat. This is a white lab rat.
It's
Okay,
a
but
New York
not a
subway.
monster wolf crazy rat thing, okay?
Cat weighs the same as one of my dogs.
Correct. So does this seem accurate?
No,
What is it a result of?
it's extrapolation.
Good. All right, we have 2 more pages, so go out, come back in, and then we're gonna finish up. 2 full pages, front and back.